So, boys and girls, I'd like your attention once more. No, I'm not going to sing. Okay. Here's our quandary. Our quandary is that we are going to take an object that is spinning, okay, like this, okay, and we're going to spin this, and the question is, if this string were to vaporize, that is, if I were to take a razor blade and cut the string, or even better, if I were to take my lightsaber, okay, and I were to, whoops, I were to cut that string right there. See, I don't think that's a real lightsaber. I mean, it's not. It's like, it looks like it's made of plastic. I can touch it. Anyway, if I were to, at the very instant that this thing is, at the very instant that it is, the string is parallel to the whiteboard, okay? If I were to raise this up and cut the string, the question is, what is that roll of tape going to do? Is it going to remember that it was attached to the string and kind of spiral its way out? Is it just going to go fly off on a tangent, like I do sometimes, right? Or the other question is it going to fly and hit that wall over there? Maybe. Yeah? I don't know. Yeah. B. F. Everybody say it all at once. 1, 2, 3. B. A lot of B's. Okay, say. A, just to be different. How many say it's going to spiral out? How many say it's going to go straight off on a tangent? Most people say that. How about C? It's going to fly this way. Yeah, there we go. Okay. So basically it boils down to this. Okay. The question is, and I think we've all guessed right. Okay. Okay. The question boils down to this: what is it doing at that moment? What is its velocity? Which direction is it going at this moment, right here?
Towards me.
It's going straight toward the back of the room, right? So let me just draw a circle. That's a good circle. That's a good circle. That's a good circle. That's a good circle. There we go.
I like that circle.
Here you have it.
Isn't she
Okay.
beautiful?
Yes, the circle. She is beautiful. Okay. Not so good at drawing the centers of circles. Okay. There is no more excitement for the rest of the period. Okay. So the circle has a certain radius r, right? And when it moves in the circle, it has to move at a tangent, right? This is always true, by the way. Whatever path you are taking, okay, your velocity is always tangent to that trajectory, yes? Isn't this true? Because there's no other way, it can't work any other way, correct?
What?
There's no way to draw a shape without having your pencil move in the direction you're drawing. I believe that's correct, okay? But it's an advanced concept, yes? So as I drew this, when I was here, my pencil was going, or my pen was going exactly to the side. Here it was going exactly there. You can always lay a tangent to it. And that is the direction that the object's going, right? So this angle right here, I believe between a radius and a tangent is always 90 degrees, yes? Okay. So if the thing, when it's here, is going toward the back of the room, yes? Okay. And we stop exerting a force on it, what's it going to do? It's going to continue doing what it was doing, yes? It's going to go straight toward the back of the room. So that's why, yeah, so let's try it. Well, I've got a simulation of this. It won't be quite as good as...
Will it explode in the simulation?
Hello. No, the simulation won't explode, but...
You should really find some simulations.
Okay. Hello. I've lost my keyboard. Hello. We are having, oh, there we go. Okay. All right, class. So here is an interactive physics simulation, and I've got this object. I just gave it an upward velocity. I've got a string, that's a constraint that constrains the motion of this, right? And most strings are there for the long haul. That is, they're there forever until we cut them. This one, though, since it's a software string, right? This one is only active when the time is less than input 7. You could click that and make it just like an ordinary string. But these strings, we have a string that can disappear after the time we put up in that box up there. Okay? Yeah, it's a magic string. Okay? What? So as soon as the time gets bigger than 17.4, the string will cease to exist, and our object will do what it is wont to do, which is what?
Explode.
Explode, no. Catch on fire, no. What does an object do in the absence of an outside force? It moves in a straight line at a constant speed, yes? Constant direction, constant speed, right? And then, of course, the constraint just quit acting, and it can't quit drawing the constraint, apparently, but there it goes, right? You see that it flies off at a tangent? Yeah, there we have it. Okay? I know.
Freaking out.
Oh, no, it gets more exciting than that, so I'm going to stop it.
It gets more exciting.
Oh, yeah. Yeah, it does. Okay. Okay, so this velocity, since it is always tangential to the circle, this velocity is called the tangential velocity. I'm getting kind of emotional here. Okay. Yes, let's all say that correctly. Shall we say it? Tangential. There we have it. Okay. Do not transpose the T and the I. Yes? Yeah, don't say it. Yeah, we're done teaching, you know, when we say that, right? Because people, yeah, there we go. Oh, thank you. Yeah, there we go. That's health class. Yeah, you're right. You know, tangential is the, yeah, there it is. Yeah. Now, here is the question, and I'll ask this question. As it goes around in a circle, which way is the force that I'm exerting on this thing? Yeah, certainly I've got to lift it up against gravity. Let's pretend that gravity is not there, right? What direction am I exerting a force on this to make it go in a circle?
Outward. He says inward.
Inward or outward? Well, if it's outward, then I have to push on the string, so let's try that. Let's try it again.
I thought it turned a little bit.
Now, I'm definitely not pushing it outward, correct? Okay? I'm definitely, which way am I exerting it? I'm definitely pulling it to the inside. So to make something go in a circle, we have to actually exert a force toward the center, and it has to actually accelerate toward the center, right? But it's a weird acceleration. It's not one that makes it go faster necessarily. It's just one that changes its direction, okay? So there it is. I'm definitely pulling this thing toward the middle, and so therefore the acceleration of this thing, the acceleration and the force are toward the center. And there's a word for this. This is called centripetal. Okay? This acceleration is called centripetal acceleration. Okay? Centripetal acceleration. And centripetal is just a big word that means toward the center. Okay? And we don't use this word anymore, except for like in physics class. Don't you wish we'd use it like in English class? Or like, or how about social studies? Right? Yeah. Before the election, the political views of politicians move centripetally, don't they? They move toward the center, and then they, of course, move away from the center, right? Afterwards, I don't know. Or how about you go into your English class and say, I noticed by the centripetal arrangement of the desks that we are going to have a discussion today. Yeah? Your goal, okay, over this next week is to use centripetal as an adjective that means toward the center, and just work it in.
Of course. Can we force it in?
No. Just work that thing in, just like a natural thing. And then if they ask you what centripetal means, just say, oh, it's an adjective. It's an adjective. It means toward the center. Yes, sir.
Can it be used as like an inward like personality, like a shy personality, like a centripetal personality?
Centripetal. Can it be used as to describe a personality? Yeah, probably. Yeah, toward the center. It would be sort of a metaphorical sort of thing. Okay. Now, let's do one more thing. Shh. Now, I know what you're thinking.